everybody, here we are talking about word problems today. We'll spend a couple days on this, and it'll lead into the crux of this chapter, which is called Systems of Equations. In this video, we'll discuss how units are super helpful when setting up and solving and understanding word problems. We'll identify if a scenario has an independent and dependent set of variables, or if instead it has two codependent variables, and discuss what that means. And we'll get there's basically going to be two general types of linear word problems we'll see. When we say linear, that means it can be written as a line. The line being in standard form. Well, first, this is slope-intercept form, or in standard form. It means as x changes, y changes proportionally. So I want you to think about this scenario for a second. There are 10 cookies. You and your brother are going to eat them. Note, this isn't a question. I've not posed a problem for you to solve. I just want us to express this situation in a mathematical sense. I want you to do a few things. Can you express the variables? Do you know what the variables are? And to give you a hint, variables are things that can change and things that we're trying to find. Can you relate the variables to each other with an expression or an equation? 2x minus 10y equals 30 or something like that. Can we create a table of possible values, and can we graph the equation if needed? Will you please pause the video and see if you can determine what are the variables? And if you can't determine what are the variables, think, can you make a table of values? Although that will be hard if there's no variables. Here's what we're trying to find in this problem. We are trying to define, or here's what we can label as a variable, things that can change what we're going to be working with. X is going to be the number of cookies you eat. Note how I didn't just say cookies. That's not specific enough. I want my variables to be as specific as possible. Y is going to be the number of cookies your brother eats. Okay, these are the things that we're really going to be working with and trying to find. Now I'm going to make a table of some possibilities. It's possible, in the best of all worlds, that I eat 10 cookies and he eats 0. In the worst timeline, I eat 0 and he eats 10. But what else is possible? It could be 8 and 2, it could be 7 and 3. In the one that makes our parents the most happy, it's 5 and 5. Notice how, because these numbers are jumping around, I don't quite have like a system or a pattern. This isn't super helpful in trying to create an equation. I can create a graph. I'm going to insert a table or insert a graph right now. It took a decent amount of time to get a good graph there. It's important that you do the same. Maybe you have one saved in Notability, or you just are working on graph paper. But I'm going to make this a really nice, pretty graph, because if it's actually pretty and precise, it can be helpful. I'm going to
note that the x-axis is cookies I eat, and the y-axis is cookies my brother eats. I'm also going to put down some numbers for scale. Just count by ones, but I'm going with every other dot, so it looks like I'm counting by twos, but I'm counting by ones. Let's graph some possibilities here.
I could eat 10, he eats 0. Best timeline. I could eat 0, he eats 10. I could eat 8, he eats 2. I could eat 7, he eats 3. I could eat 5, he eats 5. Here. Really, all of these are possibilities. Notice how that forms a line. I'm going to ask the question a little bit later, should I connect these dots? For now I'm going to, just to show that this is a line. But a question we're going to ask at some point is, should these dots be connected? Now that I know it's a line, the last thing I want to get is the equation for this line. It might not be obvious right now, but if you think about it, everything we did always had to add up to 10. 5 plus 5 is 10, 0 plus 10 is 10. Everything added up to 10 because that was the constraint of the number of cookies we had. So the equation of this graph is actually x plus y equals 10. Now I have an equation and a table and a graph, the three different ways we like to represent the data. And this equation is showing the possibilities of what could happen. Now there's a few key assumptions we have to understand. Things that we do naturally without even really thinking about it. Did anybody ever consider the fact that I could eat 2 and he could eat 4, and we don't eat all of the cookies? I think we assumed collectively that all of the cookies were going to get eaten, but sometimes you just eat some of the cookies. For the record, if we weren't going to eat all of the cookies, it would be x plus y is less than or equal to 10. Could be 10, but could be less. But that's one assumption we made, that we're going to eat all of the cookies. Another assumption we made is that we're going to eat only whole number cookies. There's never going to be a time where I eat 8.3 cookies and he eats 1.7. That's why I talked about, should we have single dots, should we connect the line? We have to think about these assumptions and if they matter. It turns out that I definitely could eat 1.2 cookies, or my brother could eat 5.6. So we connect the line, connect the dots, because everything in between is also a possibility. We could have something happening here, and something happening here, and something happening here. Another thing that we just kind of assumed is that there's no such thing as a negative cookie. Right? I didn't have negative x values or negative y values. I just used quadrant 1 of the graph. All of these things are important assumptions for us to understand that we've made. But none of this is really possible unless we start by defining our variables. It is the most important step to be able to set up and solve a word problem. Figure out what is it that can change, what is it that I'm looking for. The thing that could change is how many cookies I eat and how many cookies my brother eats. Okay. Identifying variables is an extremely important and useful thing in these scenarios. Variables are things that can change, meaning could be 6, could be 8. Things that can be represented numerically, so it can't just be cookies, it has to be number of cookies, or weight of cookies, or age of cookies, but not just cookies. And it's things that we don't know. Okay, so a variable wouldn't be x equals 10 because there was 10 cookies. That's something that we do know. What we don't know is how many cookies we ate. So just when you see a number, that number will not be your variable. Numbers are things that we don't know. I have 4 scenarios here. I would like you to take each one and see if you can identify the variables. Okay, after that we'll talk about if the variables are independent or dependent, or if instead they're codependent, but not yet. And don't try to make the equations. I mean, you can if you want to, but just take a second, pause the video, see if you can identify what the variables are in each setting. Okay, did you do it? Did you pause? If not, that's a problem. You can't just wait until I give the answer, because then you're not going to learn how to do this. An important thing about your kind of self-teaching with these videos is you have to give your brain the chance to struggle. You have to give yourself the opportunity to learn how to fight through some adversity and not just look for answers when you want them. So, if you didn't pause and think about each one, do. Also, if you don't have paper or something to write down your thoughts, that matters as well. If you're watching these videos and just sort of laying in your bed, that's not going to cut it. You should be sitting up, preferably at a desk, with a space to write. Either it's paper or another screen, or you can write on the screen of the video if that's possible with your setup. I don't care. But you should have a place to write and take notes. Otherwise, this just isn't going to go very well. Okay, number 1. There's 2 things that can change. The first thing is time. As more months pass, we get more shoes. As more months pass, we get more shoes. X is our independent variable. Time passes without us caring how many shoes there are. Even if we are or are not getting shoes, time will pass. Time is usually your independent variable. Not always, but usually. The number of shoes we have depends on the time. If it's been 3 months, we'd have 6 more shoes, we'd be at 18. When you have an independent and dependent variable, it's going to set up in slope-intercept form. This would be the equation. 2 shoes per month, starting at 12 shoes. I didn't ask you to find the equation. I'll talk more about why that's the way it is eventually. Okay, number 2. X is just going to be number of boys. Y is number of girls. Now, if you said X is number of girls and Y is number of boys, that's fine. But let's have the convention of whichever one is listed first comes first. And also alphabetical order is a good way also. This is a codependent system. The number of boys plus the number of girls is going to come out to 30. Okay, this is called codependent because the number of boys isn't going to impact how many girls there are. If we added a boy, we wouldn't have to take out a girl. We would just suddenly say there's 31 people in the class, not 30. So independent means if one variable changes, the other has to also change. Excuse me. The other has to also change. But in this scenario, the way that's set up, X can increase, and that doesn't really change what happens to Y. It kind of does in the cookie scenario, because if you eat an extra cookie, your brother gets one fewer. But it's still the safest way to think about this. Okay, you're riding your bike at a rate of 14 miles per hour. Whenever you have a rate, the 2 units will be your 2 variables. X is going to be hours. Really, it's number of hours. Please don't just write hours, say number of hours. Just get in the habit. It's going to be helpful later on. Y is going to be number of miles. And whenever you have a slope or a rate, if you're given a rate, you're going to be using slope-intercept form for your equation. Y equals 14x. X is hours, Y is miles. Notice how here time is independent again. Distance is dependent. So this is our dependent variable. This is our independent variable. The number 4 is going to be the one where it switches, where time is actually going to be dependent. So I'm going to have X equal number of problems due. And Y will be how long it takes in minutes. For example, if there were 10 problems, that would be 40 minutes. And if there were 2 problems, that would be 8 minutes. So the time actually depends on how many problems there are. This is a case where time is dependent because it's based on how many problems there are. If I gave you more problems, it takes more time. I give you fewer problems, it takes less time. So you'll notice with all of these scenarios, the labels became the variables. Whatever label we had became whatever variable we had. Shoes, months, boys, girls, miles, hours, problems, minutes. The labels are super helpful for finding your variables. Okay, here's our last. Okay, so here's a problem for us to look at in detail. Jeff has $40 and gets $5 more every 2 weeks. This right here is a rate. So I'm going to make my X variable number of weeks and my Y variable amount of money. And the amount of money depends on the number of weeks. So we're going to get better at doing this, but whenever you have an independent and dependent variable, whenever you have a rate, it's going to be slope-intercept form. Y equals mx plus b. The rate is always your m, okay? The m is your rate. Well, the rate was $5 every 2 weeks. The y-intercept is your starting point. So the y-intercept here was $40. That's where he started. He starts out having $40. Here I've identified my variables and determined if it's independent or dependent. I've created an equation. I can make a table very easily now. At 0 weeks, I have $40. At 2 weeks, I have 5 more. So at 4 weeks, I've got another 5. And at 6 weeks, I've got another 5. And then with that equation, I can put in a graph. With the equation in the table, I can put in a graph pretty simply. So here's some nice pre-graph paper. I'm going to think about my assumptions here. Is it possible to go back in time? If I have $40 today, could that mean that 2 weeks ago I had 35? Could I have the point -2, 35? I think I could. I think that's reasonable, but maybe not. Maybe I just got the $40 today, and 2 weeks ago I didn't have $35. So I'm not going to include that point, even though there's a case to be made that I could. And this is what kind of becomes frustrating and fun about math, is you can actually do either, provided you can justify it. If you can just make the claim for why you're doing what you're doing, it's pretty tough to argue with. Now I'm just going to graph these points. I'm just going to put these points on the graph, which means I've got to think, how do I fit 0, 40 on here? Well, I'm just going to call this 10, 20, 30, 40. I'm going to count by 5s. And over here I'll count by 1s, or I'll count by 2s. Just to make it simple. Here's the point 0, 40. That's my y-intercept. And then at 2 weeks I have 45. At 4 weeks I've got 50. At 6 weeks I've got 55. At 8 weeks I've got 60. There's my graph. If I wanted to, I could scale it to look a little bit different or look a little bit better. But I'm okay with this for now. I'm going to just plot a couple points. Here's the point 0, 40. Here's the point 860. This is the graph of the equation y equals 5 over 2x plus 40. I'm going to label that this x-axis stands for number of weeks, and this y-axis stands for number of dollars. I should just say amount of money, but I wrote number of dollars, so there you go. Equation, table, graph. It's beautiful. Now I can see how much money I have in any given week, or at least how the trends are changing. It's linear growth. You'll note this slope looks like it's going up 1, right 1. It looks like the slope is 1, but it's not. Can you see on this graph why the slope isn't actually 1? It's because it's not going up 1, it's going up 5. Each step is 5 units. It's going up 5. It's not going right 1, it's going right 2. Step down here is 2 units. It's going up 5 right 2 based on the scales that we have of our axes. Okay, this is a lot of stuff to wrap your head around. There's a lot of things happening here. We'll spend a couple days on it. And we'll talk about this a lot tomorrow, but there's basically 2 ways to set these scenarios up. One of them is in slope-intercept form. If you have an independent variable or a rate, like number of dollars per 2 weeks or something, that'll be y equals mx plus b. But if you have codependent variables, like the number of cookies you're eating, it'll be in standard form, ax plus by equals c. Whenever you're combining 2 things together, like 2 people eating cookies or 2 genders in a classroom or something, it'll be standard form, codependent. Otherwise, it'll be slope-intercept form with a rate. Okay, to recap, variables and units are incredibly helpful and important to set up and understand different scenarios. If you can identify if a scenario has an independent variable, problems become easier to tackle. Independent variables mean you know you have slope-intercept form. Putting down data points in a table, super way to start breaking down a problem. If you're not sure what your equation is, what your graph is, you probably know a few points, like 5 cookies, or 8 and 2. And be aware of your own assumptions. They might not be correct, and they might change things. Okay, next video, we'll practice this some more and find some ways to get hints and clues. Stick with me, okay? We'll get this figured out. Have a nice day. See you next time. We did it! We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it! You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.